Hey everyone, welcome to our lesson about modeling with the square root functions. What we're going to do is we're going to take a real world example of a square root function and a scenario that would be modeled by a square root function and use the graph to estimate some things that we see, and then we're going to verify the information that we've estimated using the function. So let's take a look at this real world example here. Let's suppose that someone is recording ages and heights of people, takes a sample of people from ages, basically newborns, to 18 years. And they record those ages and heights, and let's suppose that the picture that is drawn by those ages and height comparisons turns out to be a square root function. F of x equals square root of x plus 1.5. Let's let that model our picture. And let's let x represent the age, and that means the y-axis will represent our height. So what we're going to do is we're going to first look at the picture. Like we said, we're going to graph the function here when we have our grid. And to estimate a certain height or a certain age, for instance, we're going to take a particular number here. We're going to estimate the height of a person that would be at the age of 20. What we're going to do is we're going to have to look at the graph at that location to use it to estimate the reverse of that, the age of a person at a certain height, let's say 4 feet. We're going to again look at the graph, but it's really important to make sure we know what the variables are representing on the grid so that we can do this. All right, and then we're going to take this function and algebraically solve for these two values to make sure our estimations fit. All right. So first, the picture. So if you have a graphing calculator, or you just simply test some x values in this function and find the matching y's, you're going to get a picture of something like this. It's good to know the y-intercept, so if you plug in 0, that will give you that. So 0 is going to give us 1.5, which is here. And you can find some additional points by plugging in numbers for x, and you're going to get a picture sort of like this. It's sort of a curved, sometimes it's called a little shooting star picture. And remember, we wanted to know, we wanted to use this graph to estimate the height of someone at age 20. Well, remember our x direction here represents age for our function, and the y represents height. So it's important to remember that as we go through looking for these things. Since we cannot see that far out to 20, it's just an estimation, so it won't hurt us. We can always verify algebraically if our estimation is true. And we can't see out to 20, but we can see with our points that it's kind of leveling off out there in the right-hand direction. And if you look here, this is 5 on the y-axis. So it doesn't look like it's going to get too much higher than 5 as we travel out further. So to estimate that age, let's say we wanted to estimate the height of a person at age 20. Okay, so we're going to look at the y-axis and see where we think it might be out at age 20 on the x. And it's looking like it, I might say 5 because it's leveling off there, maybe 6. So we'll find that algebraically in just a minute to see if that's true. Right about there. And then we also wanted to estimate the age of a person who has a height of 4. We can see that one on our graph. So let's get color and look at that. All right, at a height of 4, that is here. Let's look and see where the graph is at that point. Looks like maybe it's happening right around 6 or a little bit further out from 6, maybe 6 and a quarter, 6 and a half. So we would say one of those values for our estimation. Then we can go verify algebraically to get a more accurate answer. So now to verify these things that we estimated on the graph algebraically, we're just going to substitute these values in for the variables that they represent. The ones we're trying to find, remember the first one was someone who has someone's height when they are at age 20. So if you remember, x represents our age. So since that is the case, when we rewrite our function, we are going to put our 20 in for x. And we're going to solve and calculate and try to find the matching y, which would be the height that matches that age. So we're going to put that in here. So f of x equals square root of 20 plus 1.5. Calculate it out. Square root of 20 is about 4.47. And when you add 1.5, we will get 5.9. Remember we said it could be between 5 and 6. That was the part out at 20 where we couldn't see, but we could see that it was leveling off. So that's pretty good. It matches up algebraically. All right, and then we also wanted to know the age of a person that would match to a height of 4. So it's very important to remember what our variables represent, because this time we want to put our number value in for y, since y is what is representing height. So we want to find the age, the x, that's matching the y of 4. So we're going to put it in for y this time. So we're going to do a little bit of solving to get our x by itself. We've got to do opposite operations. So move over our 1.5. And we have 2.5 equals square root of x. And to get rid of the square root, we want to do the opposite operation, which is squaring. Calculate that out. You're going to come up with approximately 6.25. And that's a good thing too, because remember on our graph, we discussed the fact that it was around 6 on the x-axis, maybe a little bit further. So let's write in our units to remember exactly what we're dealing with. This one was matching a height of 4. The age is 6.25 years. The first one was matching an age of 20. The height that we found was in terms of feet. So we want to go back and write that in so we've got the units there. And this concludes our lesson about modeling with the square root functions.